Good afternoon, and thank you for joining today's webinar from SPEC Innovations, The Path to Digital Engineering. My name is Sarah Craig, and I'll be the moderator for today's webinar. Let's go over some quick housekeeping before we get started. For those of you who may not be aware, SPEC Innovations provides systems engineering services and solutions to the aerospace, defense, and intelligence communities. Our flagship software, Innoslate, provides users with an all-in-one systems engineering software solution with requirements management, analytics, modeling, simulation, and analysis of alternative tools. We help organizations securely collaborate on critical projects throughout their product or systems lifecycle. During the presentation, feel free to send us questions using the panel on the right, and we will get them answered in the question and answer part of the webinar. The webinar is being recorded, and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now, I would like to introduce you to our presenter, Dr. Stephen Dam. Today, he will be providing you with a better understanding of digital engineering and digital threads. He will also be discussing how tool integration plays a role in digital engineering and what SPEC Innovations is doing with Innoslate to foster that role. Dr. Dam is the president and founder of SPEC Innovations. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam participated in the development of C4 ISR architecture framework and DoD architecture framework. He also received an expert systems engineering professional certification from INCOSE. He currently is applying systems engineering techniques to various DoD, DOE, and commercial projects. And now I will hand over the controls to Dr. Dam, and we will get started.
Thanks, Sarah. So I hope I'm not boring people. This is very similar to a presentation we gave last year about the path to digital engineering, except we have quite an important progress report and update that you'll see here in a little bit. So, and I do have to go over some of the basics. And we always have new people in the audience who don't know some of these basic items. So I thought I'll go through that, talking about what the digital thread is and talk about the integration aspects of it, what we're specifically doing, and when we should and shouldn't integrate tools. And then talk a little bit about some of the problems with the digital threads. So what's a digital thread? Now, this has kind of become a real buzzword, and it was really heavily driven by the DoD's digital engineering strategy put out a few years ago now. This is out of a presentation by Philomena Zimmerman, but this is one of the key charts that's out of it, showing the digital engineering ecosystem and looking at it all through the life cycle and how it supports different aspects of the problem, all the way through not just technical parts like integration and the use of the models, but all the way into the transforming the culture and the workforce. So the objectives here is to try to deliver high payoff solutions to the warfighter at the speed of relevance. And the key there is that, too often historically, we've delivered products to the warfighter and it's been too late. A good example probably was in Desert, when the Second Iraq War, where Future Combat Systems came in towards the end and finally delivered some really cool stuff, but it was sort of at the end of the fight. But again, that's still good stuff, but again, it was kind of a little late for when they really needed it. Another thing is they want to reform business practices. That's another real goal out of this. Again, to speed up this acquisition cycle particularly is one of the big concerns. And that's, of course, been a holy grail for the DoD for about 50 or 60 years now, certainly most of my life. So the thing is that the idea is that this kind of combines some of the model-based techniques people have talked about, the digital practices that we've been using for quite some time, and the computing infrastructure, which is changing pretty rapidly with the advent of cloud computing. So one of the things that they did in this very quickly after the initial strategy was developed, DoD commissioned the Air Force's research lab to put together a set of posters to explain the digital thread. And I was at a conference and captured pictures of every one of them. They had audio links explaining them as well, which would have been really nice to maintain, but that website's gone. So I never was able to keep that information, but at least I still have all the pictures and seeing what they're thinking about. And their idea is just to they showed kind of the current process here at the top, and this is one for systems engineering. And where it's about very textually based, document based kind of approach. And the idea is to move to a more model based approach. And then they give an example of that application. I've seen that working to some level. I mean, frankly, we've been doing model-based systems engineering, if that's what you want to talk about, for over 30 years. I personally have been working that using tools like RDD 100, Core, and of course, more recently, Innoslate. And so this is not a new thing, the MBSE. We just came up with a new name for it. We used to call it computer-aided systems engineering, by the way. So it's kind of interesting to hear this. Anyway, so the focus here is again on modeling, though, and the problem is that people don't always understand the models. I mean, the models are often in languages that are confusing to the average person. But ultimately, they still have to create a document because you're in a situation where you're providing a legal process, right? Because you think about what is acquisition, you go create a contract. Well, what is a contract? It's a legal document. Well, the lawyers aren't going to say, hey, yeah, we're going to accept that model as the input. You're going to have to put the model into a document form so that it can be explained and seen and looked at more in depth. And so that's an important part of it. So again, this one poster is not the whole picture. They actually had a whole set of these posters. So this hierarchy chart that I've got from Innoslate shows you all the posters, the different class of posters they had, and all the individual ones they had. So this was cutting across the entire life cycle. And so it was important to think about the tools that we're using, supporting all these phases of the life cycle, and be able to do all these things, at least support in one way or another. The tool set needs to support all these activities and probably more. Let's face it, this is probably not as complete as you might expect or might hope. But anyway, it's a good start, and it was a good way to think about it. It's a good way I keep coming back to these posters from time to time to think about, well, what are we doing and how are we helping support this? And particularly one of the keys is that we need to ensure that the systems engineering is part all the way through this life cycle. It's not just for the beginning part of the life cycle, which a lot of people get confused as just about requirements. Well, systems engineering is all about requirements, but requirements in the beginning, in eliciting the requirements, in developing the requirements, in analyzing the requirements at every level of decomposition. And then when you come back up the V, of course, you are testing or verifying and validating against those requirements. And so I have to have a means to do that. And so, of course, there's all that very pesky design engineering stuff that happens at the detailed level. And they have great models and tools that they've been using for decades in this area. And so what we want to do is take advantage of those tools. And we don't want to replace those tools. That's silly, because those tools are well-calibrated models and simulations that can provide really significant support. So what we want to do is provide a mechanism to push down the requirements from the systems side, systems engineering, into these design engineering spaces, and then trace them through that process, and then bring them back up for V&V. Okay, so one of the questions is, well, okay, so do we really have to integrate the tools? Do we want to integrate the tools? And so if you look at goal number one there, the top part of goal number one is model integration. Okay, so because the problem has been historically that tool interoperability is a huge problem. We ran into that I think I sat on an INCOSE working group for tool integration for about 20 years, and finally said, this is going nowhere because the vendors had no incentive to integrate their tools. There's currently the automotive working group at INCOSE has a project where they're trying to take three different SysML tools and have them share models with each other. And even those tools that supposedly adhere to this quote unquote standard, SysML, they can't share the models. They can't share the data. They can't share the tools. They're all done differently. They have different kinds of output. They have different kinds of input. So in fact, what we see is that's a big, big fundamental problem. So the question is, how do we go about doing this? What do we need to do? And the real question is, do we want model integration, or do we really want data interoperability? Is it the data we want to flow between the tools? Or better yet, do we really want to come up with, what does this mean? What does the data mean? How can we take that and abstract that up and create information from it? So this is the power, I think, of what we're trying to do in the digital thread. So in Innoslate, again, that fundamental problem is really a lack of an ontology for data interoperability. People have been talking about this for a long time, and I keep hearing the ontology word talked about. Well, a group of us back in 2011 or 12, I think a group of us got together and said, you know what, we really do need to standardize this language. And we need a language that we can work, that can do the systems engineering we want to do. And we want to make it simple. We want to make sure it's not just, not just narrow and for a specific domain, but something that can give us that kind of 80% solution, the start of that ontology that everybody could use. And so a group of us came together and created something called the lifecycle modeling language. Now LML is an open standard. Yeah, there are people who've claimed that, oh, that's SPEC Innovations proprietary language. It's really not at all. It is an open standard. It's completely available. If you go to lifecyclemodeling.org, you will go see the standard. It's right there. You can download it. You can see the people put it together. So SPEC Innovations supported it and worked with it and continue to do so. And we implemented Innoslate really to show the language, show the full capability of the language. It's why we started Innoslate. It's kind of gone beyond that, but still, it's really quite good. LML in 2014, it was extended to add SysML. We actually had done the DODAF MetaModel 2.0 mapping back in the original 2012 release of the standard. We continued on and worked on and added the SysML support. And again, you can see that that's really true because, in fact, Innoslate provides all the SysML diagrams. Now, do we provide them perfectly? Does somebody might think that's in some other tool? I don't know. We probably don't. Again, if there's something you think we're missing, we're happy to add it. It's not a problem for us to add things to our tool. We actually solicit user input to our tool and use it very effectively. So the real key is, though, unfortunately, right now, no other vendors have really adopted LML. There's some claims that other people can do, and of course, you can take LML and use it in other tools that can extend a schema, like Core or Cradle or things like that have schema extension. And of course, you could use it in things like Doors, where there's a schema in Doors. So again, actually Doors doesn't have a schema. I'm sorry, it comes out of the box with a blank schema. So you could start and use LML for that purpose. So again, a lot of ways to use it. It's not dependent just on Innoslate. We highly recommend it to be used, in fact, for the SysML ontology. But I guess I'm not sure quite what they're doing. So I hope that people are adopting it. We really think the government could go a long way by adopting LML and helping solve this ontology problem today. Okay, so that's one aspect of interoperability. So another thing, if you want to know more about LML, it's actually not hard to learn. You can see the comparison of the books. I've been told by the SysML experts that you need these two books on the right there to do it. In LML, we think this little thin paperback that's $15 on Amazon is sufficient, okay? Because that's what you need to do is get started. So again, if you look at LML, it's taught in a lot of universities around the world, And so people are starting to look at it, understand it, and at least to help them understand systems engineering in an effective way. By the way, LML is actually useful also for program management. It provides an ontology for program management. Again, I'm very simplifying the ontology because you don't need to have a lot of difficult capabilities with it. It's a very easy one to get started with and get moving forward with. So again, we've proven it over the last 8 years or so that since the standard's been out that we can apply it to just about any systems engineering and program management problem, oftentimes with minor extensions, which is certainly allowable and even suggested. So if you have a specific domain and you want to extend it, that's a really great thing to do. And in fact, a group at Idaho National Laboratory is creating, they call their diamond ontology. It's based on BFO, and that's something basic framework ontology or something. Anyway, and LML, and they've added their own extensions for their particular domain, and that's a great way to build, and we highly recommend that approach. So Innoslate was designed to integrate those systems engineering activities across the entire life cycle. So we start up the top with a documents view, because we know you still have to have documents. These are now digital documents. They are accessible, they're reusable, they're traceable. So you can create any documentation you need in the tool, just right in this view, and then you can do model-based reviews of those documents as you need to. Okay, and you can put in your own design type, document types, you can add in templates, you can do whatever you need to do to create the documentation set you use. We're using this on major programs right now. And then requirements view is a subset of that. That brings in our quality checker. So we actually use natural language processing technology to read the requirement and score it against various parameters that basically roll up into this quality score you see in the little bars there. And it'll give you hints for where the problems might be in terms of improving the quality of the requirement in the process. We also have an intelligence view that looks at other heuristics and in more detail, and those include a number 4 requirements, but they have many for other classes of information as well. Modeling, we have 25 different diagram and 2 chart types and counting. We are adding them all the time. The 9 SysML diagrams are not sufficient to do what we need to do, not even close. and they can double it, they can triple it. We'll never get there through diagrams. It's a fundamental lack of understanding that you can't diagram your way out of this problem. So, and of course, they've equated diagrams to models. So, you're just not ever going to have the information set you need if you take that approach. That's why an ontological approach is important. We have a CAD viewer. It needs a little rework, and we're actually going to talk about that here in a minute. But it has the ability to take a CAD file and then break it up into our physical assets, and then you can use that to help do traceability back to requirements. This is a way you can start validating that the CAD designer did what the requirements were meant to do, and so at least you can start that process. Simulation, we currently have a discrete event and Monte Carlo simulation. We're going to be looking in the very near future at enhancing those simulators and adding perhaps other simulation types as well. Test Center is where we capture our test results, expected results, actual results, our test cases. We could set up different test suites, so you have different tests for, like, if you want to do testing, your different lifecycle testing, your DT&E, your OT&E, or different specific component tests even if you want. You can set those up as separate test sets and use those. We're looking to do execution of those in the future. Program management, we have a risk analysis. So we have a risk matrix, and there's one of the chart type, that's one of the diagram types. And the chart type, we have a risk burn down chart as well. By the way, that risk chart matrix can be transformed into an opportunity matrix very easily if you want. So anybody wants to see that, let me know. And then the timeline diagram. So the timeline diagram works, again, the the tasks are basically actions, and it works with the action diagram as well. So you could start your building up your timeline diagram, and then from that you can then build a model. You can execute the model through the simulator, and then get a Gantt chart output that is a dynamic result of it. And of course, you can run the Monte Carlo to get a handle on what your risk is in terms of cost and schedule. So again, this is part of how we use it for the program management side of it, as well as, of course, you can apply that to the system itself. And last but definitely not least is cost. You know, so many people forget about cost. Cost has to be looked at by the engineering team. There's nobody else who can. People get cost and pricing confused, okay? Cost is what something costs. That's usually an engineering estimate that's required to make that happen. So we've got cost elements to track that. It ties back again to the actions in the action diagram, and it ties into the simulator. So you get a cost output as part of that simulation. So again, we've tried to look across the entire set of things we need to do as systems engineers and program managers and provide mechanisms for doing that with Innoslate today. So that gives us that top part of the digital thread we're looking at from both ends, okay? But now we're starting to look at other tools. How do we bring the design engineering tools in, many of which are desktop tools? And so that's a tough thing. We're going from cloud computing environment, which we live in, and we're a cloud native tool, into the world of desktop software. Okay, so we came up with a mechanism for doing that. We call it a Java web application. And the Java web application that was created will read get a path to where things are on the desktop or on your client server systems. And it can tie into these other kinds of tools. Now, our approach has been, well, let's go get best of breed tools and integrate with them directly. Because the last thing the user needs is a lot of fumbling around and configuring different tool sets to try to work with their tool. So we've picked some tools that we think are really top in class, and particularly MATLAB. Almost everybody knows MATLAB Simulink, one of the top ones that for doing the scientific computing types of activities that people want to do. A lot of models are created in MATLAB, calibrated, used there. Another one we're worked to and we're partner with is STK, Systems Toolkit from AGI. And AGI, they are the premier tool in terms of geospatial visualization and analytics. And the analytics part is amazing that they have in that tool. So again, that's something we're leveraging. On the development side, those are more for the simulation type of engines, is usually how STK and MATLAB are doing. So that's more that it tends to be towards the either detailed design engineering or V&V side of things. But we also have to recognize we've got hardware integration and software integration. So as I mentioned earlier, we have CAD file interface, and that's probably all we want to do. It hasn't been a CAD tool yet we've seen that we really say, oh, that's the one that's the perfect one that we want to use the APIs for and link directly. So we do use that as basically a CAD file, and that's fine because we don't need to get in what they're doing. We just need to be able to push information to them and be able to get information back. And so we are working more towards that, those kinds of inputs and outputs. In the middle there is GitHub, and GitHub, if you're not familiar, is a software repository tool. It's very similar to Jira and I guess what's called now Azure DevOps Server. They're all based on an underlying technology called Git, G-I-T, and those can be used to help you, track your software, keep your software in place, walk through, make sure you're being able to track issues, that you're looking at, branching and forking, all the things that it has. It's a very powerful tool. So we have a direct integration with it. It's a cloud-based tool, so it fits very nicely into our model. And then last but definitely not least in this bottom set is the ANSYS tool set. We've just begun investigating with them, and we're in the process of setting up a partnership arrangement with them as well. We do think they are the actual gold standard in tools like computational fluid dynamics, finite element tools. They have some great electrical engineering tools, on and on. They have an incredible set. They have a very nice interface called Minerva. And so that's probably what we'll be using to do that interface. So we'll be looking at that in probably early next year. Another couple that we're looking at very hard, Selenium is for the software testing side of things. So this is how we execute software tests. So we're looking how can we interface with that with our test center and use it to help us execute the software testing. And similarly with LabVIEW, looking at it for hardware in the loop testing. So you can see we're starting to bring all this information together in one place. Okay, and again, we're not duplicating data in databases. We're extracting from them and then showing results of things and showing and so decision makers can make the decisions they need. We don't have to get into the code directly. We don't have to get into the mechanical engineering design directly unless we need to. If we need to drill down, then you go into and look at it in the CAD tool. It's the logical thing to do. Well, if you look at the top, there's a couple other little things up there popping in. And one says HoloLens, another says voice translation. Well, the Microsoft HoloLens, if you're not familiar with it, it's a 3D mixed reality capability. And it is fairly new still. They're in version 2 of it. We'll probably it's Microsoft, so we'll probably have to wait for version 3.1.1, but you know, that's okay. It's really is something that looks like it's incredible technology. You don't have to wear gloves. You don't have to do some of these other virtual reality kinds of things that you run into. But the idea of the mixed reality is I can see my environment at the same time I see this projection. And now I can overlay information on top of on top of the real world and be able to do some pretty interesting things. Particularly, you can think about the one that people see all the time is the maintenance. So if you're trying to maintain a system and you want to go get specs, so you pull up the specs and you're sitting there working on it. There's the spec, and you move to the next page, whatever you need. So it's all right there for you, very easy to use. And the other thing that we found out with it, we didn't realize this when we first did this picture, in fact, is that the voice translation actually is already built into the HoloLens. So it very well may be the interface we want to use for the future. So this is where we're trying to go. This is research we're doing under a program for a federal agency. I'll leave it at that. And so that's actually analysis and work we expect to have some good research results in the next 6 months or so. Anyway, so the key is our goals for the integration on the right here. We want to use data to create information between the tools. We want to minimize that duplication of data between tools. Those are really our primary goals for this integration. Okay, so we call that vertical integration. The CAD viewer is currently being upgraded in version 4.4. That's scheduled for release here mid-December, we're hoping. Don't hold us to that yet. We're still always are trying to add things to that. We're in the process of finalizing the integration of MATLAB, Simulink, SDK, and GitHub for version 4.4 as well. Those are imminent. We've had other people, other colleagues who've actually integrated with LabVIEW already and created that, but it's more of a sneaker net kind of integration. We're looking to do more API to API kind of integration. And of course, we're already starting to look how can we productize the Selenium work, because we already made that connection. By the way, Phoenix Integration is also developing an integration with Innoslate per a customer's request. And we're perfectly happy to work with Phoenix Integration and other integrators as is appropriate. Don't have a problem with that at all. We again want to help people create their own digital threads in the way they need to do it. And so again, a number of customers are creating their own and using their own design engineering tools and things. But you know, one of the things we're going to want to look into is when do we want to integrate and when don't we? And we'll look at that in a minute. But I want to talk a little bit more about the when we should integrate. So let's talk about that. So again, the lack of a common ontology we've already noted is a problem. So we got to select the tools that we can integrate with very carefully so that we can map the ontologies between the tools fairly easily. So that's a key part of what we're doing. So the ontology is actually one of the biggest things we look at first. What is the ontology of these other tools? How does it map against ours? What do we have to do to extend ours or to assimilate that information? Usually is what we're looking for. And then, so again, we're selecting those for different projects. Different projects want different types, and so we'll look at those different things on one at a time as appropriate. Again, as customers want more of that as integrations, we're happy to try to help them develop it, or we can develop it. Again, there are open APIs for this purpose, so it's very easy to learn, and we can help you develop those things and develop common import-export formats as well. Our XML is it's open. We have an XSD for it, so it's something you can easily learn, pick up and use. You're not in data lock with our tool at all. And again, note that data flows in many tools are really one directional, but we have to do bi-directional. So that's actually very important for us. So we are thinking about that in terms of what we're doing. Do we want bi-directional? Do we want one directional for this vertical integration? Again, remember, our job as systems engineers is produce specifications for design engineers, then take their results and import them into our database. If nothing else, SneakerNet's fine for that. There's nothing wrong with having that gap, okay? Because, and again, that seamless integration between maybe just a bridge too far. So think about this. When do I really need to do this? Should I really be doing this? Do I have a point where I can inspect and see what's going on, okay? It's much like you look at an automotive engine today, right? They have lots of test points. So they don't have to just dismantle the engine to figure out what's going wrong with the engine, right? They don't have to do that anymore. They just use the test points. You build in the test points for doing this. The same thing is true between the design engineering tools and the systems engineering tools. You want to understand what that model is telling you, because I hate to tell everybody, but we don't know everything. We don't know all the physics behind many of the simulations we have. We calibrate the models as best we can for the environment and situation we have, but there's still quite a bit of analysis and engineering that goes into that. So you got to watch the garbage in, garbage out phenomena. It's very easy to have these simulations lie to you. And create an actual digital twin, which I keep hearing those words talked about, you wonder if that's even feasible. Okay, so a little bit more about 4.4. Again, slated for release in December 2020. And so this is the MATLAB SDK interface together. So what we've done is we've now simplified. There was actually a lot of scripting that we had to create when we did this originally to go between the APIs. But what we've done is now we've created our own special commands for this purpose. So we have the ability to pull, do MATLAB posts, MATLAB gets, for example. Similar with STK, we're doing the same thing with STK. So this allows us to move the data easily back and forth between the tools. So it works great. This is really going to be working with the discrete event simulator primarily. I'm not sure how well this would work with the Monte Carlo. We're still testing some of those capabilities. This will also, by the way, be an enterprise-only feature. It's not going to be a cloud feature because, again, you have to have that access to the desktop in a more reliable fashion. So that doesn't mean you can't put our enterprise version on a cloud and use it. You definitely can do that. We are doing that right now. So don't think that you were losing that. But again, this was actually showing you an actual thing of looking at a rover on the moon, going and doing a search pattern as part of, if you've seen my new book, Real MBSE, we talk about this whole idea of mining the moon. So on continuing the 4.4, some of the other things, this is now more the design engineering integration side of it with the hardware and software. So we have a new CAD viewer, brings in all kinds of new types of CAD files you see up at the top or left there, color, material information, things like that. We even have the ability to upload a zip file, which has your OBJ and MTL files, your material file together, and we unzip it for you and then create that picture. And so you get it looks like it's going to be very nice. That is going to make 4.4 something we pushed hard for to make that happen. The GitHub, which is a lot of the other bullets that are here, are very critical. My guys kind of overachieved on this one. They created actually a whole new viewpoint called GitHub. In it has lots of different things: a Kanban board, issue tracking, pull requests, commits, statistics, and you see some of the examples here from it. And so it's very, very comprehensive in looking at what's going on in GitHub. It's very, very pleased to see that result. But one of the also very exciting things is that we take code and create from that a class diagram. Okay, I've seen other tools do this. My biggest problem is they didn't abstract it very well. And so you got everything. It was overwhelming. So you might as well have been reading the code. Was what we've done, I think, is a pretty good job of coming up with a good abstraction level that's appropriate at the systems level that I can now trace back to my requirements. And so again, right now it's a manual trace, but again, our goal is to push these issue trackings down, turn our requirements into what they call issues in GitHub, keep that through the process, and then make sure that's available here. And then now we have a way maybe potentially to automate the traceability all the way back to the original diagram. So this is baby steps. We're still working this through, but I think we've got a pretty good handle on how to do this and have something very effective and very powerful. Okay, so with that says what we decided to integrate and how we decided to integrate. So how do we not, why should we not? So again, I mentioned the physics-based simulations are only a portion of the physics needed. I worked at Los Alamos National Laboratory when I first started, and I learned the hard way that the simulation tools will lie to you. Because we don't know the exact physics. We don't have the math to do the nonlinear problems solutions in it completely. So a lot of what we did was extensive calibration to experimental data. It's gotten much better. I mean, let's face it, the simulators are much better. But again, if those have certain boundary conditions to them, and you don't know what those are, you need to find out. because if you extrapolate beyond those boundary conditions, you're more than likely going to get a false result. And we've actually seen that in quite a bit of even some of the public things going on in the simulation. Anyway, so again, pushing poorly or non-analyzed simulations results in the system level, you're going to be introducing more errors than you're solving. So again, this is where you want the air gap. You want that analyst in the loop, looking at the information, making sure it makes sense, making sure it should be pushed forward. So what are some of the problems with digital threads? Well, there's a lot of issues still with this whole idea of the digital thread. You see the picture on the right. Most of you probably recognize this. This was the Death Star. You do remember what happened to the Death Star. Someone got the plans to it and they figured a way to blow it up. Okay. And so that's exactly what you worry about. You worry about someone getting that much information about your design and now it becoming a security risk. Of course, another part of that is you may have tremendous amounts of data storage required, okay, to actually fully express all the information about a couple of jet engines is, I think it's in the petabytes regime. So we're at numbers that we're just not used to even thinking about dealing with, how to store and find and search. So that's a big part of this whole model curation activity that's going on. Is how do we deal with this data? How do we make sure it all fits together? Another big concern that's been posed is mixing intellectual property rights. That's a big difficulty as well. But how we overcame these problems in the past, we partitioned the problem. We always have had this problem. This is not a new problem. This has been going on forever, right? Because we're almost always overwhelmed, no matter what level of technology we have. It's too much for the human to absorb by themselves. So that's why we create systems that would partition the information and break it up in a way that we can work with it and do what we need to do. And so that's a key part of what we're doing still. So that's another thing about the tool integration thing. You got to be careful about that part of the problem as well. So again, if we just apply the common sense things we've always done in this area, we can still do the digital thread, making the data flow well between things, keeping it consistent, and avoid these problems by doing partitioning. And again, that's just a basic property of what we do in system engineering. So that's what we need to be thinking about. And in Innoslate, we have our mechanism for doing that is something we call cross-project relationships. We have you put information in different projects, and then you can identify who has access to that information and who doesn't. And so you can, but things can be shared between projects as you want to. And so that's we think getting very close to what we need to do for this, solving this partitioning problem. Okay, so kind of in summary, you know, LML we think is a path to future systems engineering. We think it's an important part. We need that kind of a simple, easy to understand ontology people can pick up and use effectively. We want, if we're going to do digital engineering in the future, we got to be using the modern tools. Okay, we went cloud immediately when we saw the scalability requirement that's needed for this, for the work we're doing. Cloud was the only answer right now. We don't have optical computing yet. Okay, so maybe when we go there, maybe that's what will take us to that next level. But right now, cloud computing looks like to be our best tool for that. And using artificial intelligence, natural language processing, machine learning, things like that. Other 21st century technologies as they come in, we want to adopt them, we want to use them, we want to bring the HoloLens was another good example of that. These are things that are emerging technologies, and we want to adapt, we want to embrace them and move forward with them so we can have the true future of systems engineering. Again, we recommend using LML in any and all systems engineering tools. That would help this problem of the tool data interoperability. And of course, you know, you can't, I don't think you can design future systems using old methods and tools. Most of the stuff that's out there was designed back in the 1980s and 90s. And let's face it, it still looks and operates the way it did back in the 80s and 90s. We've come a long way since then. So we need to embrace these new technologies, not hamper them. I still think this is my vision of Innoslate version 20. It's Jarvis. So anyway, we look forward to making Tony Stark's lab a reality in the future. So I think we've got some time for questions. I'm just trying to leave a little bit of time for that.
Thanks, Dr. Dam. We've already received a few questions, so if you haven't done so, please send your questions to the panel on the right. Feel free to ask as many questions as you have, and Dr. Dam will answer as many questions as he can before our time is up. So our first question is on slide 9. Could you please touch on more detail on how to input, manage, report the workforce skills within the tool?
Sure. So that's the workforce skills and training. So one of the things we have in there is the ability to treat people as assets. Okay, so people are assets and they have different skills, which we can capture as characteristics. We can even set up the training programs, which are mostly processes often that you want to set up. If you look at the instructional system design that's used in the DoD particularly, that's actually a systematic way of doing training and developing your training. So you can use it to help you develop that training, and then we use it also to store our training. Our training products are artifacts. We upload them and track them and can keep them curated to make sure they can really do what we want to do.
Thank you.
I hope that answers the question.
The next question is on slide 12. Please briefly talk on if you address the SysML diagrams with Innoslate.
Yes, we have, again, all 9 SysML diagrams are just 9 diagram types that we have of the modeling side of this. We also have class diagrams, we have use case diagrams, we have, what else? That's that we have IDEF 0, hierarchy charts, there's this timeline diagram, the risk diagram, we have layer diagram, which is the way you often draw it in PowerPoint. We have an interface control diagram type that we created ourselves. We were looking for a standard and didn't find one, so we actually created one that we think is pretty good. On and on and on. And many of these diagram types are coming from suggestions by users. So we're very open to that, and we want to go beyond what SysML is limiting us to.
Thank you. Our next question is on slide 13. GitHub is good, but talk about the possible use of JARA connectivity with Innoslate. We are still in the process of down selecting between GitHub and JARA.
Okay, sure. Now, I don't know much about Jira, so I can't really speak to it very well. But again, our understanding is they have the same fundamental type of API information going back and forth. So we think it's fairly easy actually to add Jira to it. And part of our goal next quarter, actually next version 4.5, we'll be looking to expand that to include Jira explicitly. So you can pick either one. So the idea here is let's make it so you don't have to choose between them. You can have either or. I mean, ideally, we'll make it so you can have both. I don't know how that will work, but we can certainly try. So let us know what your needs are.
Our next question is the goal of LML to be able to talk to DODEF, SysML, and all other systems, or create a new method everyone will use?
Yes, it's both. So what LML provides is that underlying ontology that supports DODEF, SysML, all these other systems. We can map it to BPMN. We know we can do that. We can map it to anything. I've mapped it to dozens of other ontologies that people have created. So the idea is LML gives us that really strong foundation we can work from and then build out from there. We went through, when we created LML, we looked at a variety of other ontologies were out there and tool ontologies, and tried to come up with what we thought was the kind of, what's the right word, Rosetta Stone for all this. So you can easily map to all these other approaches and techniques, and we're happy to do that. It's really not a big deal at all. As you get into using it, you'll see it's very simple. But it also has some new stuff to it too. For one of the things we did with the action diagram, which is our behavioral diagram, we took a cue from electrical engineering diagrams and realized that we want to have something that is a very simple instead of having constructs, what we have is a special case of the action. Now, what that allows us to, because those types of points are called decision points, and decision points are something you want to capture because this is the way you embed your information assurance, your security, things like that are embedded in this, in command and control. So it's important to have that capability. It's very unique to LML at the moment.
Thank you. Our next question is, which languages are supported by the code modeling?
So the code modelers these days really work in terms of their own languages like Java and C++ and R and things like that. That's the language they are working in. If you think about that, that is an abstract language itself, because what that is a mechanism for the human to interface with the computer, and that gets converted through the compilation process into binary. So the computer can just flip the ones and zeros at the right time. Okay, so that's where they prefer to work today. The agile programming is all about doing that. You do small amounts of code at a time, and you keep the code as simple as you can as you go through that process. UML was abandoned by the software development groups. It started being abandoned in 2004. So if you Google UML, for example, and do a Google Trends, take a look at that curve. It decayed exponentially. Peaked. It shows a peak at starting. Well, it only starts at 2004. Okay, and it's only gone down since, and now it's flatlining to being low. So I don't see that being a good approach, and that's another reason why we kind of object to SysML as being pushed as the standard for systems engineering. It's not speaking to anybody. It doesn't communicate with any group of people I know. And so, in fact, what we've been finding is that when people do their SysML drawings, the guy who drew the drawing understands it, and almost nobody else really gets it fully. So that's bad. That's real bad. So anyway, that's been our experience, and you know, we're I'm sure other people have other experiences, but that's what we found.
Thank you. Our next question is, if I need a particular diagram which is not part of LML, can I create the symbology and behavior of the symbols to achieve it in Innoslate?
So we actually do that for you with things like the SysML. So the activity diagram, we provide that, but I'm not sure we have the ability to do exactly what you're looking for built in. I'd be interested in knowing more of what you're thinking with that. So feel free to send us a suggestion if you use our cloud version, our regular cloud version, you can send it. There's a feature request form that you can put it in there, or just send an email to support@innoslate.com. So we're happy to think about what it is you're trying to do and how we might be able to accommodate it. Okay.
Thank you. Our next question is, do you have examples of your HoloLens visualizations?
No, not yet. We are just learning it. I must say, I actually personally tried to play with it and found it difficult for me. But I'm an old guy, so I gave it to somebody young. So hopefully they'll figure it out. I just didn't have the bandwidth for it.
Thank you. Our next question is, with regard to the code translation to class diagram tools, what languages are currently supported and what languages are planned to be supported?
So our current support would be for Java. That's the main one we did, but we're certainly open to other languages, and what would they be? I don't think it'd be hard to create a similar kind of capability with other languages. So again, tell us what you like, what you want, what you need.
Our next question is, how does Innoslate integrate with tools like System Composer and add-in for Simulink and MATLAB, since it seems like the requirements in architecture traceability has some redundancy between those tools? Are they complementary?
Wow, okay, so I don't know what System Composer is, so I'm sorry, I can't really answer that question. What we did was realize that we wanted to have the full capability for systems engineering program management in one tool, which is Innoslate. We don't recommend going between tools to try to do different requirements. That was one of the reasons we built Innoslate, so we didn't have this problem. But again, I'm sorry, I wish I could answer that question more in depth.
Thank you. Our next question is, can Innoslate integrate with Onshape, an in-cloud CAD tool?
So we think so. We actually did some work with that this summer and looked at, we had some interns looking at Onshape particularly, and really liked it a lot. And we think that could be. We probably wouldn't standardize on it right now just because it's expensive. We went in to look at the actual cost of it, and to try to use that was a little prohibitive. So we think if people are interested in that, though, there's no reason we can't help you build the APIs you need. And that's true with any tool, by the way, that you choose. We may not be able to do it all ourselves, and we don't want to. We're happy to make the APIs and help you learn how to use the APIs to do this. And part of why we're doing this is that we'll end up with examples of code that we could share with you so you can do this yourself. And that's another, I think, really benefit of this project. It is government sponsored, so once we get full delivery to the customer I believe they're going to allow us to use the code snippets we've created, since they're government procured, to make them available to other people, and that's our goal.
Thank you. Our next question is, what is your revenue model for Innoslate? Is this a server application, i.e. enterprise license, or is this a client or user license structure?
Yes, we do both. But it's mostly subscription based at the user level is usually what people do. But we have provided, we can provide an enterprise license across an enterprise if need be. And we're happy to discuss that.
And the next part of the question is also, since it is cloud native, what kinds of cloud resources are required for implementation of the Innoslate capability, and what security implementation have you recommended?
Oh, okay. So we're actually in the process of getting a STIG with DISA. We are in that process, so we will actually have a security technology implementation guide. I think that's what STIG stands for. So we're going to have that capability. We are currently operating on NIPRNet and SIPRNet through the U.S. Navy Systems Engineering Resource Center, which also doubles as the Air Force's Systems Engineering Resource Center. So NSERC, AFCERC. And so that's for NIPR, SIPR, and then we're on the IC Marketplace. So kind of everywhere you need to be.
Thank you. And our next question is, are there any other design engineering tools you are looking at integrating Innoslate with in the future?
Yes, I don't know what ones yet, though. Right now we're focused on the set I showed you, which is pretty big already. But again, we're open to hear about other ones that we think we need. We think we've hit most of the domains pretty well with this set of tools. But again, I'm sure there's stuff we're missing. So happy to listen and hear if there's something else we should be adding to this group. And sooner to tell us that, the better, because again, I have this wonderful research program that's government sponsored, and if that can interest them into us looking into that, we might be able to do that in the next 6 months. So that's another thing we can look at during that period of performance for this contract. So if that helps.
And what kind of database does Innoslate use for the back end, for data backend, like document database, graph database, and SQL database?
So right now we're SQL database structured. On the cloud, we use Postgres, and on most of our enterprise users are using Microsoft SQL Server. And then of course there's also something called H2, which is something we can load on a desktop. So if you just want a desktop version of it for some reason, we can even produce that. We used to be on a graph database. We were on Google Big Engine, which was a graph database. The problem with that was a variety of things. Google kind of decided they weren't going to pursue the government environment like Microsoft and Amazon have. So since that's primarily the area we want to support, we kind of migrated off of Google for that. But we're looking at various graph databases, and we certainly would like to do that again. We need to find a portable one. Neo4j has often been brought up as an example. I've certainly flirted with that a few times, but it's certainly something we can look at for maybe version 5 of the tool, is to see if we can interface with the graph database.
All right, and our last question is, does Innoslate allow integration of specifications mapped back to requirements or end-to-end traceability?
Oh, yes. I mean, in fact, what we do is usually take, you create specifications, of course, within the tool, but also you could take a specification, import it into the tool, and then break those into more detailed requirements. And then you can link it to the end-to-end traceability. That was the whole idea of the tool, is so that now I track everything all the way through the life cycle. And so I have the ability to now do that full end-to-end traceability.
Thank you. That concludes the question and answer portion of the webinar. We would like to thank you again for joining us for today's webinar. Make sure to join us next time for our next webinar, What is the Lifecycle Modeling Language, on December 2nd at 2 p.m. Eastern Standard Time. As always, we will also send the recording and slide deck to everyone that attended today. We would also like to make a quick announcement that the Model-Based Systems Engineering Conference's registration is now open. MBSCCon will take place virtually on February 22nd through the 24th, 2021, and will focus on MBSE through interactive panel sessions, experience keynotes, and workshops. To learn more about MBSCCon, please visit their website at mbsccon.haysummit.com. For more resources, we encourage you to visit our website and our blog, as well as connect with us on social media through the Innoslate user group or through Twitter using the handle @Innoslate. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar. Please enjoy the rest of your day.